Pickle and Protobuf might be the secret sauce behind your AI models, but they rarely get the spotlight they deserve. Why do these unassuming tools play such a pivotal role in machine learning pipelines? In this video, I'll reveal how Pickle and Protobuf streamline data serialization, boost efficiency, and enable seamless model deployment. If you've ever wondered how your AI models handle data so smoothly, it's time to uncover the magic behind the scenes. By the end, you'll understand why Pickle and Protobuf are indispensable for modern AI workflows and how they can elevate your projects too. Pickle, Python's serialization workhorse. Pickle is a standard Python library that converts Python objects into byte streams for saving to disk or transphase them. If you're a PyTorch user or scikit-learn enthusiast, chances are your model weights and checkpoints are powered by Pickle under the hood. From .pt and .pth files to .pkl objects, Pickle is everywhere in the Python ML ecosystem. Strengths: native to Python, seamless for Python development. Flexible, can serialize almost any Python object, including complex models and training histories. Limitations: security risk. Unpickling files from untrusted sources can execute arbitrary code, which is a severe vulnerability. Poor interoperability. Pickled files cannot be read outside Python or across different Python versions or ML frameworks easily. Protobuf, cross-language, production-grade serialization. Developed by Google, Protocol Buffers, or Protobuf, is a binary serialization format designed for performance, portability, and extensibility. It's the backbone of TensorFlow.pb files, ONNX models, and Apple CoreML formats, making it indispensable when models need to jump between platforms or programming languages. Strengths: compact and efficient, extremely small file sizes and fast, especially with the C++ implementation. Language neutral, designed to work across dozens of languages, Python, C++, Java, and many more. Strong schema support, uses .proto files to enforce robust structure and backward compatibility. Limitations: more setup required, needs a schema definition and code generation. Not human-readable. Unlike JSON, you can't just open a Protobuf file and read it. We're unlocking the secret sauce behind how machine learning models save, transfer, and load data, with a spotlight on 5 major file formats: Pickle, Protobuf, JSON, flat buffers, and message pack. When it comes to raw serialization speed, flat buffers and message packs steal the spotlight, built for high-performance environments like mobile apps and edge devices. Pickle, while Python native, is fast for quick saves, but not as lean or lightning fast as the others. And yes, Protobuf makes the cut, offering impressive efficiency, especially when paired with compiled schema. Need cross-platform access. JSON, flat buffers, and message pack are language agnostic and thrive in ecosystems where flexibility rules. Protobuf also shines here thanks to its .proto schema, bridging Python, C++, Java, and more. Pickle, however, stays loyal to Python, great for in-house workflows, but not ideal for interoperability. File size. When saving space matters, flat buffers and message pack deliver ultra-compact files. Protobuf also minimizes overhead with its binary format. Pickle and JSON tend to create slightly larger files, especially when rich object states are involved. Security. In the realm of security, Pickle has limitations. It can execute arbitrary code if misused. Safer bets include JSON, flat buffers, and message pack, which focus on data-only transfers. Protobuf, while structured and secure, requires schema diligence. Use in LLMs. Pickle is the backbone for frameworks like PyTorch and scikit-learn, ideal when you're staying in Python land. Protobuf, on the other hand, powers giants like TensorFlow and ONNX, enabling deep integration with multi-language ML ecosystems. JSON and others play peripheral roles, useful but not foundational for LLMs. Human readability. Only one champion here, JSON. It's clean, readable, and perfect for debugging or configs. The others, including Pickle and Protobuf, binary beasts. Fast and efficient, but you'll need tools to peek inside. From rapid prototyping to cross-framework deployment, each format brings unique strengths. Whether you're building in Python, serving models in C++, or optimizing edge inference, understanding these serialization engines is key to mastering your ML workflow. You would prefer Pickle over protocol buffers, Protobuf, for your machine learning projects in the following scenarios. 1. Python-only workflows. Pickle shines in projects fully contained within the Python ecosystem. If your model training, saving, and loading are all in Python, and you don't need cross-language compatibility, Pickle offers the easiest and most seamless serialization experience. 2. Quick prototyping and experimentation. For rapid prototyping, when you frequently save and load intermediate models, objects, or experiment results, Pickle is fast, requires no schema definition, and works out of the box. 3. Complex or custom Python objects. If you need to serialize objects that aren't easily mapped to standard data types, e.g., functions, class instances, custom layers, Pickle supports this natively, unlike Protobuf, which requires explicit schema definitions. 4. Saving Python-specific state. Pickle is excellent for saving not just models but also Python-specific information, like training states, optimizer objects, or even Lambda functions, without additional configuration. 5. Small-scale or in-house projects. When the data model files are only accessed by trusted parties and you don't need human-readable or interoperable formats, Pickle's security limitations are less of a concern, and its speed and flexibility are a benefit. Avoid Pickle if you need cross-language sharing, long-term backward compatibility, or if your serialized models or data will be exchanged with untrusted sources. Protobuf or other safer formats are preferable. But for fast, flexible, Python-centric ML workflows, Pickle often provides the least friction and the most productivity. Protocol buffers, Protobuf, significantly enhance interoperability across different machine learning, ML, frameworks through several key mechanisms. 1. Language and platform neutrality. Protobuf uses a language-neutral and platform-neutral schema definition, .proto files. These files describe the structure and data types of messages in an abstract way, independent of any particular programming language or platform. Code generators, Protoc compiler, use these schema files to automatically generate data access code for various languages, Python, C++, Java, Go, many more. This allows ML models and metadata to be serialized in one framework and read in another, regardless of language. 2. Standardized serialization format. All Protobuf implementations produce and consume the same binary wire format. This means you can serialize data in, for example, TensorFlow or ONNX using Protobuf in Python, and then parse and use that data in C++, Java, or even Go in another framework, as long as the schema is shared. This fixed wire format eliminates the need for custom parsers or converters when exchanging models or data among frameworks. 3. Use in major ML frameworks. TensorFlow represents computational graphs, tensors, and model metadata internally using Protobuf. The TensorFlow.pb files, saved model, frozen graphs, are all serialized with Protobuf, enabling other tools to load and manipulate them as long as they can parse the common schema. ONNX, Open Neural Network Exchange, a widely used format for moving models between PyTorch, TensorFlow, and other frameworks, also uses Protobuf to describe model structure, metadata, and parameters. Because both TensorFlow and ONNX describe their models using .proto schemas, tools can convert, inspect, and modify models regardless of their source framework, fostering a high degree of interoperability. 4. Versioning and extensibility. Protobuf support for backward and forward compatibility means you can add, remove, or change fields in model schemas without breaking existing tools that consume the older or newer formats, which is essential as ML frameworks and their capabilities evolve. This ensures that model files remain compatible across frameworks and library versions, supporting smooth upgrades and exchanges. 5. Real-world example, cross-framework model conversion. Suppose you export a model from PyTorch to ONNX, and then run inference in TensorFlow or serve in an edge device using C++. The underlying protobuf files let all these environments parse the same model structure and parameters as long as they share the ONNX or TensorFlow protoschema. In summary, protocol buffers act as a universal language for structuring and serializing model data. By defining models, tensors, and metadata in protoschemas, ML frameworks can save models in a format that any compatible tool or language can load and interpret. This leads to seamless interoperability, flexible deployment, and easier ecosystem integration across the whole ML workflow. Wrap up. Why does it matter? Pickle enables quick, flexible model saving for prototyping and research, ideal in Python-centric, controlled settings. Protobuf powers robust, production-ready, cross-language LLM deployment, handling massive models with strong schema guarantees. Other formats like JSON, flat buffers, and message packs serve niche roles, but Pickle and Protobuf remain the backbone for most mainstream LLM file formats today. So next time you're loading a .pt, .pb, or .onks model, remember, Pickle and Protobuf are silently doing the heavy lifting to make AI magic possible.